Welcome back to Math 103. This is video number 16 on fair division. We continue our discussion of resolving a three-way standoff within the lone divider method. We are not given enough information to say where exactly they're going to put down the orange cones in new positions when Eve, Fred, and Hank apply the lone divider method among the three of them to the newly formed supershare. We don't know, we can't say where those orange cones are going to go, but we can say something about the total value of the supershare to each of the three players, and that's what we've been doing for Eve and Fred. We now do this for Hank, for whom the supershare is worth a total of $475,000 when you add it up. So he will receive a share worth at least a third that much. He'll receive a share worth at least a third of what he thinks this entire supershare is worth. And that's a slightly messy number, $158,333.33. So if he happens to be the divider when Eve, Fred, and Hank go to work on this supershare, if Hank happens to be the divider, he'll get exactly this amount worth of land, and if he happens to be a chooser, then he has the chance of potentially getting more than this dollar amount. It is possible that at this second stage, where they're applying the lone divider method just to the supershare of S2, S3, and S4, it is possible that there will be a standoff again here. Now, wait a minute, I thought we were already resolving a standoff. How could there be another standoff at this stage? That is possible, because whoever the divider is going to mark off three plots of land. He's going to put down these orange cones and mark off a share here, a share here, a share there. And suppose, for example, that Eve is the one who is the divider at this stage. That leaves Fred and Hank possibly involved in a standoff, say, over this share, because when they see the way Eve has put the cones down, they both really want this piece right there. Or maybe they both really want this piece right there. Or maybe they both really want that piece right there. So how do we handle this? We handle it by the same logic that we've been using thus far. Suppose, to make this specific, that the standoff is over this piece of land right here. Fred and Hank both really want this particular share. So we take either one of the other shares that's not involved in the standoff, and we give it to Eve. Now she's taken care of, so she's done, and that leaves us with this remaining bit of land, these two shares as Eve marked them off, which now have to be merged into a single share, a single supershare, that Fred and Hank are going to have to divide up between the two of them. How will Fred and Hank divide it up? Well, they'll have to use the divider-chooser method, because there are two players and one piece of land remaining, and our method for dividing up a set of continuous goods between two players is the divider-chooser method. Let's use the understanding we've built up so far to see how the lone divider method will generalize to n players, in other words, to any number of players greater than 2. Okay, so we've seen how it works. We've seen examples of 4 players and 5 players. In fact, this will work for 10 players, 100 players, etc. So first, you accommodate as many players as possible, each with a fair share from his or her bid list. We set aside any shares and any players who are involved in a standoff. So at the very least, the divider is going to get a fair share, because the divider can certainly live happily enough with any one of the shares that he or she has already created. At worst, everyone else is involved in a standoff, but the divider won't be. So at the very least, we can take care of the divider at this stage. Now, only those involved in standoffs remain at this point, which the divider was not. So there are at most n-1 players still to be taken care of. So if n was the starting number of players, then at the very least we take care of the divider, and that means that at worst there are n-1 remaining players who still need to receive fair shares. Now we should note that there could be more than one standoff. It could be that over here you've got a standoff over share 1, and over there you've got another standoff between other players over share 2. That could happen. Each standoff that occurs then becomes its own new mini fair division problem. It becomes a fair division problem subsidiary to the problem we started with. And it's resolved by the players involved in it using the lone divider method, if there are 3 or more players involved, or the divider chooser method if there are only 2 players involved in the standoff. As we've seen, there might again be standoffs during this second stage. So when we're resolving standoffs, there might even be standoffs subsidiary to the standoffs, but no matter what, they will not involve the dividers at that second stage. So when you go into a new subsidiary fair division problem to resolve a standoff, it will have a divider, and that divider will certainly get taken care of and not be involved in any further standoffs. Okay? So we're always making progress. At every stage, at least the divider or dividers at that stage are all getting taken care of. We're always ending up with fewer people who still need to have their standoffs resolved. So we just keep doing this. We keep applying the lone divider method, or perhaps the divider chooser method, to resolve each standoff which arises. So even if there's a new standoff at each stage, we're still making progress toward giving everyone a fair share, since we can always accommodate at least one new player, namely the divider, every time we apply the method. Please go on to the next video.